Ladies and gentlemen, welcome to our presentation today. Hopefully you can enjoy it. Firstly, I want to say thank you to Professor Xie Jin Su, Department of Electronic Engineering, National Kaohsiung University of Science and Technologies, for giving me an opportunity to stay here to talk about my journeys after finish one half of this course. Um, After finish my presentation, I'm so glad if you give me some advice or some comment to me improve my skill in the future. Okay, let's start. Before going inside our content today, I will give you a small example to have an overview about what is heuristic. I firmly believe that all of you also already played this game. This game called Tic-Tac-Toe. Let's considering the game of tic-tac-toe. Each move in the first 9 moves has 8 possible best possibility in the chess piece, and each move in turn have 7 possible chess piece for the next move. A simple analysis indicates the number of states that needs to be considered for the process that is 9 times 8 times 7 times 1 equal 9 factorial. Apply a small visual command based on the symmetry of chessboard configuration. Actually, there are only 3 moves for the first piece: in the egg, in the corner, and in the middle square. Reduce the number of possible paths in the Z-space down to a total of 12 multiplied with 7 factorial. It was smaller than the original space, but still going in the factorial function. Here is our contents. Define 3 parts. The first part is introduction, heuristic meaning. I know that all of you learned it already, but I need to repeat one more time for you to fully understand what is heuristic meaning. The second part is some heuristic optimization methods. We have random walk, hill climbing, genetic algorithm, particle swarm optimization, and colori optimization, simulate aliasing, taboo shot, Bernoulli algorithm. Because the limited time, just 15 minutes, so I focus in genetic algorithm. And the last one is my problem, my challenging. Want to show you. First, introduction. The heuristic means to find or to discover. Heuristic methods is a procedure that is used to find the optimal and desired for solving problems more quickly. It does not guarantee and not accurate algorithm, but it may be considered as approximately. Long time ago, we have often heard that the human evolved from the Asian ape. This view comes from the Charles Darwin theory of evolution, and genetic algorithm definition comes from Wikimedia. It said that in computer science and operation research, a genetic algorithm (GA) is a meta-heuristic inspired by the process of natural selection that belongs to the larger class of evolutionary algorithms (EA). Genetic algorithms are commonly used to generate high-quality solutions to optimization and search problems by relying on biologically inspired operators such as mutation, crossover, it means sexual recombination, and selection. In this slide, I will talk about a history of genetic algorithms. Developed by John Holland, University of Michigan, 1970. The purpose to understand the adaptive process of natural systems, to design artificial system software that retain the robustness of natural systems. The original form of GA, as illustrated by John Holland in 1975, has distinct features: a bit-string representation, proportional selection, and crossover to produce new individuals. Several variations of the original GA have been developed using different representation schemes, selection and reproduction operators. You can see this is John Holland. He is American scientist, also the founder of genetic algorithm. To in order to explain the appearance of the giraffe, the Charles Darwin hypothesized that in the deer population, exceed the deer with the higher neck already. During the develop and living, the changing of environment make the food more and more difficult to find. That's why the deer with the higher neck can be dominate and can be survive until now, and the deer with a short neck going to die. The basic idea, a class of probability optimization algorithms inspired by the biological evolution process, use concepts of natural selection and genetic inheritance take a population of candidate solutions to a given problem. It operates inspired by the mechanism of natural genetic variation. Apply selective pressure towards certain properties involve a more fit solution. And I have a table to you easily compare between natural and GA. In the natural, we have environment, GA optimization problem, individual living that environment, feasible solution, individual degree of adaptation to its surrounding environment, solution quality, population of organisms, a set feasible solution, selection, recombination, and mutation of inner natural evolutionary process, stochastic operators, evolution of population to suit the environment. In relatively applying a set of stochastic operator on set of feasible solution, and another table for natural evolution and GA. Chromosome is like bisting, actually bisting like chromosome, stringing position like gen, value of certain position like alleles, something like that. In this slide, I will talk about the relationship between the component of genetic algorithm. Population, an initial population will have a certain individual with different characteristics. These characteristics will be determine the ability to reproduce, survive, and the ability to meet environmental conditions of each individual. Natural selection over time, weaker, non-viable individuals will be eliminated by factors such as food chain dispute, toxic environments, and destruction by other species. Finally, the more permanent individuals will be retained adaptive individual. Mutation, as we know, each born child will inherit the characteristic of both parents. After a period of living time, a population will set to the limit of the gen pair of children made up gen of parents. In order to achieve evolution, mutants are not of the main cause contributing raw material to natural selection process. And evolution, mutants are not always strong and capable of survival. Natural selection selects mutants but can adapt to the environment better than other individuals in the population. After a period of reproduction, the mutant gene will dominate and make up the majority of the population. To have more detail, I will describe the under picture here. You can see totally we have 10 butterfly, and at the generational first generation, I call generational yellow, we have 10% dark color butterfly. It means that one butterfly with a dark color, but after several generations later we have 18%. It means 8 butterfly with a dark color. Genetic algorithm can be explained by many ways, but the formula will not change. We have start initial population, then evolution, fitness, then selection, then crossover, going to mutation. If to the seal solution is going to end, but if not, keep going to a loop here. In this slide we'll talk about the benefits of GA. Of course, concept is easily to understand. Modular separate form application supports multi-objective optimization, good for noisy environments. Always an answer gets better with time. Inherently parallel, easily distributed. Many ways to speed up and improve a GI-based application. As knowledge about problem domain it can easily to explore periods of alternate solution, feasible building block for hybrid application, substantial history of and drain of use. And also, we also have some application of GA. We have some field, some domain. Control gas pipeline, design semiconductor layout, aircraft design, set up the scheduling, manufacturing, robotics. We have trajectory planning, machine learning, design, neural network, improve classification algorithm, classify system, signal processing. We have filter design, game playing, poker, checker, combinational optimization, set covering, traveling salmon. And the last one is my problem, my challenges. It is traveling salmon problem. A given is a salmon wishes to travel around a given set of cities and return to the beginning, covering the smallest total distance. Hopefully after finish this course I can apply the heuristic method and solve this problem and can apply in the real life. See you in the final presentation. Thank you for listening and That's all about my presentation, and see you in the final presentation. Thank you for listening.